Welcome to Rex. In this video, we'll be learning about how to use Rex to create a histogram. Histograms are a type of bar plot that group numerical data into bins of equal width. Each bin is plotted as a bar whose height corresponds to how many data points are in that bin. Let's first take a look at our data. Today we are using the Fisher's iris dataset, which is a classic in the field of statistics. The iris dataset contains 4 features: the sepal length, the sepal width, the petal length, and the petal width, for 50 samples each of 3 different iris species. Let's say we first want to create a histogram that visualizes the distribution of sepal lengths. In order to do so, we can go to Graphics and Histogram. We'll first be using this Variable tab to select the variables to plot and to define the grouping variables. As we can see, the headings in the first row of the Excel datasheet are displayed under All Variables. We can use the arrow buttons to add or remove variables from each option. Let's first create a histogram that plots the distribution of sepal lengths for the entire datasheet. In order to do so, we will select sepal length as the variable of interest. Next, we click OK. In this histogram, the heights of the bars tells us how many data points are in each interval of sepal lengths. For example, let's take a look at the interval between 6.875 and 7 centimeters. Here, the histogram tells us that the dataset has around 5 iris samples in this interval. Using this histogram, we are able to see the distribution of sepal lengths for all of the iris samples. Let's say we want to make a new histogram that has wider and less bins. In order to create a histogram with a different number of bins, we can go back to Graphics and click Histogram. As we can see, the settings that we made for our last histogram are saved. Because of this, sample length is already set as the variable of interest. We'll go next to the Output tab. We can use this tab to customize many parts of our graphs, such as changing the graph style, adding marginal plots, and customizing the legend, and more. In order to create a histogram with a different number of bins, we will change the number of bins from 30 to 10. Finally, let's click OK. In this histogram, we now see that the data is divided into 10 wider bins. Now that we have a good idea of how our variable is distributed for the entire dataset, let's make a histogram that shows the frequency distribution for each species. We go back to Graphics, Histogram, and let's reset our settings to the default options. We'll then add sepal length again as our variable of interest, and now we will add species as our grouping variable. In the Output tab, under Multiple Groups, and we are able to choose the plot style. The default is a stack plot. Let's see what this histogram looks like first. Here, this histogram shows each iris species in a different color. For example, the Setosa species is shown in red. We can also see that this stacked plot shows the stacked sum of the frequencies for each interval of sepal length. The advantage of the stacked plot is that we are able to see the distribution of the whole sepal length variable, but it is difficult to compare the distribution between each species. In order to compare the distribution of sepal lengths between each species, we have to make a dodged plot. To do this, we'll go back to Graphics, Histogram, keep the same variable settings as before, and under Multiple Groups in the Output tab, we will now select Dodged Plot. Let's click OK. Now we can see that the frequencies for each species are displayed side to side with narrow bars. In addition to the stacked and dodged plots, Rex offers 2 other styles for histograms with group data. One is an overlapping plot, which displays multiple overlapping histograms where each group is shown in a different color. And the last one is the faceted plot, which splits the plot into a matrix of panels where each panel shows the different groups. Now, let's create a new histogram with the density estimation curve on top. A density curve is a smooth, continuous version of a histogram estimated from the data. To do this, we go to Graphics, Histogram. Note that I've already reset the settings to the default options previously. We will then choose sepal length as the variable of interest and species as our grouping variable. And next, in the Output tab, for this histogram, we want our y-axis to display the probability density as opposed to the frequency that we had before. Now we can see the density curve has been enabled. We will select it and click OK. Here we can see a histogram and a curve on top. The curve is the density curve estimated by the kernel density estimator. We can also use Rex to perform statistical tests and output the results on our histogram. Let's say we want to output the results of an ANOVA test on our histogram. To do this, we go to Graphics, Histogram, choose sepal length as our variable of interest, species as our grouping variable, and in the Output tab, in order to perform statistical tests, we must select Overlapping Plot. Now that the statistical test section is enabled, we can use the test method, customize the text size, and the position of the results, and select whether or not to include a vertical mean line for each group. Today we will select parametric in order to perform an ANOVA test, and we will include mean lines for each group. Finally, we click OK. Now we can see an overlapping histogram with the mean line for each group, as in species. We can also see the ANOVA test p-values on the top left. Here, the p-value indicates whether or not the difference in mean values between each species is statistically significant. Notice how the p-value is less than 0.0001. This means that the mean sepal lengths between each species has a difference that is statistically significant. In our final histogram, we can use Rex to add a variety of elements, such as a marginal plot, a vertical line, and a custom x-axis. To do this, we'll go to Graphics, Histogram. We will choose sepal length as our variable of interest, species as our grouping variable. And in the Output tab, under Marginal Plot, we will select Box Plot. For the relative size of the box plot compared to our histogram, we will keep it at a default of 0.2. Next, we will click Grouped to output a separate box plot for each species. Next, the Add Element tab can be used to add straight lines to our graphs. Let's say we want to add a reference line that indicates a sepal length of 6.2 centimeters. To do so, we will add a vertical line with an x-intercept of 6.2. Next, in order to make this a thick lotted line, we will set the line width as 1, and we will select the dotted style. Lastly, we will set the color of our line as pink. We then click the arrow button to add it to our graph. Finally, in the Miscellaneous tab, we can use this tab to customize and label certain axis values, as well as to do any other customizations for our graph. Let's say we want to show that our sepal lengths are in centimeter units. To do so, we enter the x-axis value and enter the label that we want for that value. Here we want it as 5 centimeters. We then click the arrow button to add the label tick value to our list. Now we will repeat this with 6, 7, and 8 centimeters. Now that we are done customizing our graph, we can click OK. Here, we can see a histogram and a series of box plots on top. The box color is the same as those inside the histogram, showing a species. We can also see the point that indicates an outlier. On our x-axis, we see that the centimeter labels that we set are there. And finally, we can see a thick pink dotted line at 6.2 centimeters. Overall, as we have seen in this video, we can use Rex to create and customize histograms. Thank you for watching today's video in Graphics in Rex Pro. Don't forget to like and subscribe to RexSoft's YouTube channel for more informational videos on statistics, data, and how to use Rex.